Of reflection. DNA replication is a complex of tasks due the human genome's vastness containing around 3 billion base pairs. However, despite this size of emphasize a protein within our cell of facility to expedite this process. It's having specific function allowing for a quicker reflection process. During the initiation phase of DNA reflection, several key components like vital roles. Intention. The case begins reflection from the origin of replication and within DNA strand from reflection from the linking hydrogen found of using energy from ATP hydrolysis. Routine. Prevent a single stranded DNA from rebinding and maintain separation. DNA polymerase generates short RNA sequence polymerase about 10 nucleotides long initial editing reflection at the origin polymerase synthesize this polymerase process of the comments. DNA polymerase reads the template strands and adds complementary nucleotides from new strand in 5 to 3 direction. It is helpful in providing a recurring error. Number 2, leading strand is synthesized continually in the same direction as the reflection for movement, luminaries attached once and processing along smoothly. 3, lagging strand synthesized in the opposite direction of the reflection fork, requiring the luminaries fragments called the Okazaki fragment to do to the opposing direction of template and synthesis. In the termination phase of DNA reflection. Termination DNA polymerase removes RNA polymerase added for the initial with help RNase. It fills in the gaps and assists in preparing the newly synthesized strand. DNA luggage. Cells gap between Okazaki fragment from by polymerase on the lagging strand prepares it to double-stranded DNA. C. Completion application of the process of finalized when all primary removed gaps and failed legacy, leading to initial sets of genesis cells of complete reflection about or do multiply. Organism reflection transcription. An RNA processing during a transcription segment of DNA copy into RNA, mRNA by RNA polymerase steps involve the binding of RNA polymerase to promoter DNA, creating a transcript of bubble, adding an RNA nucleotides and forming RNA strand. The nucleus processing. The nucleus archaea structure in the nucleus are suitable for RNA transposition processing and ribosome assembly. Nucleus processing. The nucleus archaea structure in a nucleus is suitable for RNA transposition process and ribosome assembly. It acts as a factory producing ribosome equal of protein synthesis. It serves a hub for large-scale RNA production and ribosomal subunit and assembly to meet these demands.
Ribosomal RNA genes of the organization of the nucleolus. The nucleolus lacking of membrane organized around specific ribosomal causing essential ribosomal RNA genes RNA polymerase of transcribes 5.85, 18S and 28S. RNA is forming 45 is particular RNA cells. Cells contain multiple copies of these genes, special for ribosome production normally taken in copies using of creation of vast ribosomes with this per cell. Processing of RNA nuclear regions contain a protein RNA genes actively transcribed by RNA polymerase of forming and this is structure resembling of Christmas tree. In addition of microscopy processing of primary of 45S per RNA involves cleaving separating specific of extensive base of modification guided by small nuclear RNA RNP is there are complex SORNPs. Ribosomes assembly. Ribosomes assembly involves combining ribosomal particular RNA with the ribosomal proteins and 5S RNA ribosomal protein genes are transcribed outside of the nucleus, while 5S and RNA genes are transcribed by RNA polymerase. These comments are assembled in the nucleus into ribosomal particles with the ribosomal proteins transported from the cytoplasm. Eventually, the nuclear ribosomal subunits of 40S and 60S are formed of this process. The nuclear matrix again of the cytoplasmic matrix comprises the protein-based framework within the nucleoplums. It provides structural support of nucleus and adds of organizing its contents. This matrix currently composes the fibrous lamina, including lamins of the associated proteins of the attached to inner nuclear envelope. Within the nucleus of proteins are the fibrillar network providing support of chromatin and the nucleus moving up. It plays role in regulating DNA replication of transrepetition of processes. Nuclear indicator cell death can be indicated by nuclear change, recognizance of splitting, kyosis, fragmentation, karyolysis, dissolving. Transport occurs nuclear transport is from signals like nuclear location signals, NLS. Reporters recognize these signals of the translation of cardios through nuclear paths. The transport is essential of nucleus 40 PDA performed by the carposes in years of importance in mammals. In NPC can be handled 1000 translocation events of sequence renewing with each cell division. Amino acid sequence serves as important import-export signals ensuring effective of nuclear transport. These are two examples, import and export. Chromatin. Chromatin DNA is from nucleus, compacting DNA from nucleus with mitosis, break prevention, and gene regulation. Tetromacromatin detecting contracts with it. And chromatin active genes like glutinous translocation factors are maximally shape of chromatin. Remodeling complex of modified systems impact expression DNA instructions of chromatin architecture. Histones. This process of identify the histones in the nucleus of them during chemical studies with the event secreted later publication in the virus tissues revealed histones and main chromosome. Continuous of fundamentally based on the signal of protein. Additional relevant 5 major histone groups H1, H2A, H2B, H2P, and H4. Electroproteins of confirm this strength of histones of therapeutic tissues. Histone modification including acylation and methylation are observed on site-specific epigenetic marks. There are ways to remodel chromatin and ATP dependent nucleosome remodeling cause of transition histone of modification and specific histone replacement of nucleosome structure resolution ethnic of histone plasmid when positive forming of converged histone fold motif. This motif along with the DNA handling of quickness of think of nucleosome complex regulating access to the process like of transplantation. Unstructured N-termal histone serve of points of regulation of higher order chromatin structure. N-termal histone which basic reproduce lack of secondary structures and interact with the DNA, influencing higher order chromatin structure. Type size of histone effect of chromatin conformation of the tails and interact with the chromatin containing enzymes of enclosing transcription of repair and replication machinery of recombinant. The histone code. Histone test is the equivalent of modification form of a histone code. This code involving acetylation, methylatation of phosphorylation, ubiquitination of thomylation, and ADP resolution and regulates DNA function through a complex combination of redundancy sized by molecular proteins. Histone acetylation involves act of transferring acetylase group to lines reduced in the histone endermal cells. This neutralizes passive change of resin chromatin structure for linear complex formation. Identified the 1960 acetylation enhance the genes of transformation of resulting transcription factors of chromatin remodeling complex. Acetate the hydrolysis revealed the histone acetyl as a natural process. Studies of with C4 divided deciduum acetylate with histone acetylation of RNA polymerase of function depending of each gate of RNA synthesis with acylated histone in the dose-dependent manner. Chromatin immunoreplication. Dictionary of prophets of chief case of studying DNA binding of seeds on the genome, offering valuable fitting into the protein of interest function. This will be used of method spans of disciplines like an circular differentiation of tumors, suppressor gene of silencing, and the impact of the histone modification on gene expression.
Chromatin assembly. Chromatin assembly is essential for studying DNA-directed processes and understanding dynamic changes in cellular chromatin that impact gene expression. These processes involve depositing a H3 to H4 to tetramer, adding to H2A to H2B dimers to form a nucleus-small core particle. Maturation with ATP for nucleosome spacing and incorporation of linker systems. This leads to nucleofilament folding into the 30 nm fiber organized into specific domains in the nucleus through subsequent folding events. Two models, solenoid and zigzag, describe the 30 nm fiber structure. Organization and evaluation of the nuclear glue. Nuclear organization involves chromatin distribution from nucleus to large-scale chromosome territories. DNA looping facilities interaction between distant elements, influencing gene expression and regulation. Chromosome arrangement affects properties with distinct territories in the nucleus. Tight folding of DNA approximately 2 meters in length requires mechanism for controlled organization. Changes in nuclear organization contribute to cell identify and impact cellular functions. Genome organization varies among organisms, with genome size expansion correlating with complexity. The ratio of coding to non-coding DNA reflects genome complexity. Nuclear organization. Macroscopic-based methods of eukaryotic nuclear reveal subnuclear organisms. Nuclear bodies like transcription and splicing. Insulator proteins concentrate in distinct nuclear systems, adjusting the leader chromatin to specific compartments, possibly forming insulator bodies. Nuclear organization involves spatial chromosome arrangement at the periphery, with lamina associated